Good afternoon, everyone. Maybe this time is sleepy time, so if you feel sleepy, so please do not hesitate to sleep. Okay, so my presentation. So today I want to talk about this new concurrency model for Ruby 3. This presentation talked by in English, but if you feel difficulty, so please please see this presentation resources. So I prepare Japanese scripts, so you can read in Japanese if you want. So at first, so visiting to the RubyKaigi schedule page, so we can see there are so many concurrency talks. So it means that it's like a concurrent RubyKaigi. So at least we have 2 parallel sessions. So why people love discuss concurrency? So this is maybe it's because of performance. So people want to run Ruby program in parallel to improve performance. Just now, MRI can't run threads in parallel, so people discuss how to do that. So today I want to talk about why multi-thread program is difficult and why we need another abstraction for Ruby. And I want to introduce our idea named Guild for Ruby 3. I'm not sure this abstraction or this name keeps live, but I hope we can discuss about that. I'm Koichi, living in Tokyo. I'm a developer of Yelp and GC or something, internal features. And I'm an employee of Salesforce Heroku. Okay, so I want to talk about the difficulty of multi-thread programming. So how many people listening previous talk in this room? So many people. So I believe that you understand why thread is difficult. So multi-thread programming is difficult. So before discussing about that, I want to show some history of program language evolution. So there is 2 metrics, two trade-off things, so performance versus safety or easily. So we want to make a faster program, and also we want to make a safety and easy safe program and making program easily. And some cases these performance and safety are trade-off. So I'm sorry, I'm not a Ruby programmer, but a C programmer, so I want to use a C program language example. So for in C programming language, we need to use a pointer to manipulate strings. So it is very nice because so if we use pointers, we can control everything. And in some cases, we can manipulate string operation very fast. However, it is very error-prone, so it is easy to generate some bugs and cause unexpected behavior or segmentation fault. So it is absolutely we don't want to do that. As the Ruby side, so we use only string class, so well managed methods. So it is easy to use, but some cases it is slower than C programs because we can't control everything. For example, using pointers. Also, she doesn't have a garbage collection. So it is great because we can control everything. However, we need to manage all objects of lifetime. It is very difficult for, at least for me. And Ruby has garbage collector, and we don't need to care about the object lifetime, and we don't need to free everything. And also, there is a disadvantage. So, for example, we can't control garbage collection very in fine-grained control, and also introduce some overhead. So we have performance advantages and disadvantages on this side. So Ruby choose safety and easy approach. So Ruby use string, so well-managed string class, and also Ruby has a garbage collector. I believe that nobody want to make program without garbage collector nowadays. So I think that I love this approach, and so Ruby encourages happy programming, so to reduce the programmer's cost. And now computer is so fast, so we don't need to such a small overhead. And some implementation techniques are invented, and the performance is grow and grow. Back to the multi-stage program. So we have many difficulties on multi-stage programming. So for example, it is difficult to make correct programs because, for example, we can introduce race condition or data race problem, and also we can meet deadlock or live-lock, and also it is very difficult to debug. So because of non-deterministic behavior, so it means that it is difficult to reproduce same issue. So this is a difficulty to make a correct, bug-free program. Of course, we want to make bug-free programs, but it is difficult on multi-threading programs. Also, it is difficult to make a fast program using multi-thread programs, using multi-threading. So I want to introduce this data race and race condition. So this is I want to use a traditional bank transfer program. So quoted from this blog post. This blog post write this program in C-like language, but I translate to Ruby-like language. So this method, transfer one, try to transfer money from this account to this account. So if the balance is not enough, then return without any with nothing. And also, if we from account has enough balance, try to transfer money. So this is very simple program. We can understand very easy, but there is a problem. There is several problems on multi-threading. First of all, so this line has a data race problem. So I don't describe everything because I have no time to explain everything. So using this order, it produces unexpected result. So we expected the result is 310, and the last result is 110. So this is bug. So to avoid such a problem, we need to introduce some locks like that. So locking this line and locking this line. So So we can avoid such a dataless problem. But we need to, so there are another problem. So it is very complicated, so maybe it is difficult to understand, but the conclusion is it can produce the unexpected result. So this line want to assert that the from accounts has enough balance, so that's the result is not so not expected. So to avoid this race condition problem, we need to log everything on this case. I hope you understand why thread is difficult. And there is another question. So prepare array object 1, 2, 3, and thread, one thread concatenates this thread, another array to this array, and show this array in another thread. So what happened on this case? So do you understand? Do you know the result? So if you think 1, 2, 3, then please raise your hand. Oh, several people. And number 2, 1, 2, 3, 5, 6. Also several people. And number 3, 1 or 3, 2. So many people. Thank you so much. The answer is depends on the interpreter. On MRI, we can see 1, 2, 3, or 1, 2, 3, or 5, 6. So the answer of MRI is number 3. However, on JRuby, it can cause exception, Java exception, not a Ruby exception. Because the array concat is not a thread safe. So it doesn't mean that JRuby should make array concat thread safe, but I want to say that it is difficult to use multi-thread program. So if array concat is thread safe, but it can cause some methods can be thread unsafe methods. So we need to understand which is thread safe and which is thread unsafe. It is very tough work, I think. So this is this program make many threads and many so repeat many operations, concatenate operations, and it causes such a Java exception. Okay. Of course, this program is very short, so it is difficult to reproduce such a Java exception, such an unexpected behavior. But we can get. So it is possible, I want to say. So the difficulty is we need to track all of objects, all of sharing mutable objects. Correctly means that we need to understand every program completely. So we need to know which method is thread safe and easy to. So on small programs, such as previous example, it is easy to understand. Oh, it is shared object, and this method is thread unsafe. So we need to introduce some locks. But if you make a big program, and especially if you use gem program written by other people, so you can understand everything to make a correct, safe multi-thread programs. I think it is very, very hard. So in other words, so multi-thread program requires completeness. So you should be a complete person. I can't believe that. And also, so because of non-deterministic behavior, the debugging is very difficult because backtrace may not work well because the problem may be placed on another line. And so with small data, such as a small example, there are no, so it is not frequent errors. But with huge data, so if you're running programs on real world in your production, so it can cause some unexpected behavior. So this is why thread programming is very difficult. By the way, array concat is thread safe for MRI because of giant virtual machine logs. So GVL protect to prohibit to run programs threads programs in parallel. However, GVL protects such a operation atomicity. So GVL helps improve the productivity a bit on multi-thread programs, but performance is not good. So tuning. So I want to show another difficulty about performance tuning. So please check this program. So this program concat arrays, so different arrays. So and using join, so it is similar to serial program. So there are no parallel programs. This is not a parallel program. So it consumes 8 seconds. And this program can run these codes simultaneously. So it reduces execution time. So it is faster. It's okay. It's great. However, if we introduce a mutex object synchronization, so we see the performance down. So of course, this mutex object is not necessary because A1 and A2 is independent. But some conservative person can introduce such a useless logs. Also, if someone tried to use same logs on that, so this is similar to single thread programs because only this line can run not in parallel, and the result is 15 seconds. So it's too slow. So this is a summary of execution. So this means that if we log, so we need to introduce logs or synchronization correctly, or if we log some logs, then it will cause unexpected behavior, or too much logs or too much synchronization, there are performance penalties. So this is why I say that you should be complete person to write multi-thread programs. Okay, there are many synchronization abstraction. However, all of them they assume we can use them correctly. So in other words, these mechanisms assume developer is complete person to use them. I can't believe it. So to overcome such a thread difficulty, we have some idea. So the biggest problem is easy to share mutable objects. So we can share. So on multi-thread programs, each thread can share mutable objects and easily to access. So the basic idea is do not allow to share mutable objects without any restriction. So basically, prohibit to share such a mutable objects. So study from other language. So there are other languages to do such a to do such ideas. So for example, consider shell script. So if we use a pipe operator between some commands, and so each command can run in parallel, and all of data passed by copy with pipes. And Alan or Elixir do not, so it is very so too heavy approach, I think. So do not allow mutable data. Everything is immutable. And also, Clojure language, basically, they do not allow mutable data. And if we need to share mutable data, we need to use another data structure, another special data structure. They guarantee such a thread safety. By the way, if you don't know the Elixir language, there is a good book. So, okay. Okay, so this is a summary of these existing approaches. So communication with copies is the easiest way, but so we don't need to consider about locking. So everything is isolated. But it is slow. And also prohibit mutable data. Everything immutable world is good. Because, however, maybe you use many write operations. So it is unacceptable on Ruby. Also, providing special data structure for mutable objects to guarantee such a synchronization, so it is good. However, it is difficult to use special data structures. So I want to correct everything good points on Ruby 3. So I decide our goal for Ruby 3. So I consumed 25 minutes to explain the background. So our goal for Ruby 3 is we need to, I listed. So we need to keep compatibility with Ruby 2. So compatibility is our biggest concern for us. And we should make a parallel program. And also we shouldn't consider about locks anymore, like multi-thread programs. And also we can share object with copy, but the copy should be fast. And we should share object if we can. So it means that the immutable object should be shared easily. And also we can provide special data structure to share mutable objects. To achieve such a goal, I invented new concurrency model for Ruby 3 named Guild. So it is so at first it is very easy. So Guild can contain several threads, and each thread can contain at least one fiber. So we can make several guilds, and each thread in same guild they can't run in parallel with giant rock. So it is the same as Ruby 2. However, other threads belong to other guilds. So T1 and T can run in parallel. So it means that T1 and T2 belong to guild 1 can't run in parallel. However, T2 and T3 can run in parallel. So it means that the guilds can run in parallel. And the important thing, the most important topic is object membership. So all objects, all of mutable objects should belong to only one guild. So this object belongs to this guild, and this object belongs to this guild. And the other objects belong to other guild. So for guild 2, he can't touch these objects. So it means that all objects has membership for only one guild. So using this membership abstraction, we don't need to consider about logs because there are no data sharing, no data race, and no race conditions. If so if all guilds use only one thread. But we need to communicate to each other, so we provide a guild channel object to communicate objects. And we introduce two communication methods. So one is copy, and one is transfer membership, or shortly, simply move operation. So copy is very easy to understand. So this method, transfer, sends deep copied objects to a destination guild. The Ruby and multi-process system or distributed system can use such kind of communication. So it is very easy. So if you want to transfer this object from this guild to this guild, so O1 refer to O2 and O3. So we need to copy everything this object can reach. So maybe it is easy to understand. The next move operation is new technique to reduce such a all copy overhead. So using transfer membership changes the membership of objects. So the target objects leave from the source guild and join to destination guild. So after that, prohibit access from source guilds. So for example, if making a string object named obj and transfer membership to another guild, and if you touch this object, then it should cause error. So we can understand, oh, this object is transferred, so we can't access to that. And also, touch by parameter, it should be error, but someone says it should be show some useful information to debugging. So we need to understand, we need to consider how to do that. Okay. So this is a picture shows a moving operation. So if you want to transfer membership for O1, then move everything. So it shows, so after moving the guild objects, from guild 2, they can access to O1 and O2, O3. And after that, from guild 1 perspective, transferred objects should be invalidated. So we can access these objects after that. So it is faster than the simple deep copy. And also we can share, we should share immutable objects. So immutable object is not a frozen object. So for example, this array, 1, 2, 3 dot freeze. So A1 is immutable because array is frozen and 1, 2, 3 also frozen. So everything frozen, so it is immutable object. So we can send A1 easily. However, this object, this array A2, it includes a mutable object as the second element. So A2 should not be immutable. So we only need to send reference to transfer such an immutable object. So it is very lightweight. So it is so we need to use such a immutable data structure more and more to improve the communication performance. So numeric objects and symbol true, false, such as special objects are frozen, immutable from Ruby 2.0 to 1.2.2. So there is a Japanese traditional word, こんなこともあろうかと. So I prepare such a frozen object to achieve such a transfer. So this is a picture how guilds, so how two guilds can access O1. So O1 is immutable, so every guild can share, can read. But immutable, they are immutable objects, so we can't read. We shouldn't read. We shouldn't write. We can't write to this one. So there are no considered as a race condition or something like that. So I want to show some several use cases. So making some worker, this example shows a Fibonacci worker, so they can communicate, and main guild and Fibonacci guild can run in parallel. So if there are many Fibonacci guilds, so we can run, we can send such a request and get response asynchronously. Also, we can make a pipeline model. So please assume that this object is mutable. And also, we can move, not copy. So moving to this guild and do something, modify this object, and moving this to here, and moving here, and modify. And the modified object return to this main guild. So this is one of the pipeline model. Also, we can make a banking example I introduced before. So only one bank guild can, so if only one bank guild maintain such a mutable object, mutable states, so we don't need to care about the locking. So, but there is several overheads. So we can't run such update these some objects in parallel, and there is a transfer overhead. So we can introduce some other special data structures. So for example, making a software transactional memory special data, special object, or using the external RDB. So it is easy to maintain such a mutable states. So I list several points, but there is no time, so I skip these slides. So this is so we need to make so we need to consider the communication strategy. So we need to assure. So we need to design using passing immutable object or copy immutable object or moving transfer membership mutable object or using the special data structure if you need performance. So the below is fast. However, it is difficult, I think. So at first, we need to consider the upper cases, as upper methods. So compare with the thread and guild. So on thread, it is difficult to find out which objects are mutable and shared objects. But on guild, so basically no shared mutable objects. So it encourages safe and easy programming, and I believe this approach makes a programmer happy. And on the threads, inter-thread communication is very fast because we only need to send a reference, but it causes several locking problems. But on guilds, inter-guild communication introduces overhead. However, move operation, transfer membership operation can lead to such overhead, I believe. So this is a trade-off, performance or versus safety and easily. So I want to choose safety and easily. So I want to show some implementation difficulties or implementation points, but I have only 3 minutes left, so I skip these implementation techniques. So I uploaded this slide, so if you have interest, so please check it or ask me later. So performance evaluation. So in fact, we can't run Ruby program other than main guild. So I make a C program to invoke the guild. So Fibonacci guilds are implemented by C program language, and also so we have 2 core, and preparing 4 Fibonacci servers. So we can get 2 times faster. So it's good data, and making a summation, compute sum of array, numeric array. So it's a very huge array, and move it, copy or move it. So copy and move is very slow because move needs. Copying is slow. It is reasonable. So it is because it is very big array. However, moving is very slow. It's not reasonable. So this is because moving operation needs check all elements. So if we understand all elements are immutable, so we only need to move the data, array data. So it is very fast. So this is why we need to implement some special data structure or support NRA or something like that. So checking all of goals. So I think all of goals are satisfied by guild abstraction. So summary, I introduced why threads are very difficult and propose new concurrency abstraction named guilds for Ruby 3. So we don't implement everything, but I hope we can discuss more and more about such a more concurrent, more higher abstractions. So thank you so much.
英語で発表してくれてありがとうございます。質問はありますか？はい、どうぞ。
So every guild can receive message from channel, right? Mm-hmm. But like in Erlang, they can have pattern matching to match which message you want to receive. Mm-hmm. But now in your proposal, there's no way to distinguish what is sent.
Exactly.
So will we introduce something like pattern matching, or we'll find our mechanism for that?
Yeah, we can consider about that, like Alan. So actually, Go language doesn't have such a pattern matching, right? So I think I'm not sure it is a problem or not. So we can discuss more and more later. Any other questions?
Yeah. So in the guild model, there are still threads, right? For
Sorry?
compatibility mostly.
Yeah. So in one guild, so thread model is compatible with Ruby 2.
So what's your plan? Because if with guild we want to introduce a model that's like free of race condition and things like that, but you would still have it if you have the possibility of multiple threads per guild.
Yeah. So my plan is, so if people understand thread is very difficult, so people choose guild and drop multi-thread programs.
But some libraries will keep spanning threads, for instance.
So
should it be prevented or?
I hope such a library replaced to other one.
Okay.
ギルドはなんか好きそうなんですけど、もともとやりたかったはずの2つのスレッドからアレイにコンキャットするっていうのはどうやったらギルドが速くなるんですか？
The question is how to solve the array concat example with guild. So the basic idea is do not do such a thing, such a mutable thing. So I bring such an example because I want to show how thread programming is difficult and how easily to introduce such a shared or mutable objects.
日本語でお願いします。
なんて言ったっけ？
クンカットをやらない方がいいという。
スレッドでは簡単にああいうことをやってしまうけれども、そもそもできないんだったら他の方法を考えるんじゃないですかっていうところが言いたい。
なんか使い方間違ってるケースが多い気がするんですけど。はい、
おっしゃる通りです。使い方間違ってることが多いので、それを使い方を間違わないような方法を導入しようというのが。あれを見て、はい、
コンキャットをやめようと思う人がいるかどうかが分かんなくて。
なんで？
分かんないです。なんか随分粒度が違うような気がします。
はい。だからああいうことができないようにしようっていう提案です。もっと別の考え方しようぜ。で、日本語ですいません。アクターモデルとかで、スレッドの上で作るライブラリの場合はもちろんそれをエンカレッジするようにしてるんですけれども、そうではないなんていうか。その気づかないミスを放置してしまうっていうところに問題意識がありまして、絶対そういうミスができないような方法を用意しようっていうのがギルドの、提案です。
じゃあギルドにスレッドなくなるってことですか？
なくなるといいなと思ってます。
はい。in your guild system, the efficiency of move operation is important. Yeah, that's right.
Sorry, what's the question? So move operation is important. Yes.
Efficiency of move operation.
Yeah. So move operation is for the performance.
Yeah.
So if you don't need to care about the performance, so copy operation is very straightforward, I think.
Yeah. But in your benchmark, the efficiency is not so good, I feel.
I see. So in some cases, yes.
Yeah. Is there any idea to improve the efficiency of move operation?
So copy on write technique is very straightforward to improve the copy operation. So I'm not sure how to make faster for move operation just now. So if you have any idea, please tell me.
is there any previous work?
What do you mean that?
なんか
source code?
なんか他に誰かこういうことをやってる人いないんですか？
Existing
Yeah,
research.
existing work.
I'm not sure. Sorry.
Thank you.
One more question, and then I think our time is up. Yes.
So how is the ownership of the global variable or classes? They are not immutable, and we want to share between guilds.
It is very good question. So we need to consider many things. So global variable or some other variables. So basically, we need to separate the global variables for so isolate global variables for each guild. So global variables should be guild local variables, and so on. So so I consider several points, but I can miss several other points. So I want to find out by implementing the guild.
はい。
Okay.
ありがとうございます。
Thank you so much.